Hi everyone, in today's video we will solve for all the values of x that satisfy this equation. And the equation involves a power series where the coefficients are exactly the Fibonacci sequence, defined as follows. So I suggest you to grab a piece of paper and try this problem for your own before I share the solution right now. Now the first thing we will do is see which values of x can be in fact a solution, since this value of f of x is equal to 1 over 3, so it is convergent. But a power series only converges for the following values. X has to lie between minus r and r, where r is defined as follows. So let's first calculate the radius of convergence. So we know the definition of Fibonacci, so we can now divide both sides by fn plus 1. So that means fn plus 2 over fn plus 1 is equal to 1 plus fn over fn plus 1. And now we can take the limit from n going to infinity. And then we get that this limit is equal to 1 plus the limit of n going to infinity of fn over fn plus 1. But now notice that we can write these two limits as a function of r, since this equality holds. So this first limit is just 1 over r. That has to be equal to 1 plus the second limit, which is r, because the fraction is swapped. So now we just need to solve for r. So this gives us that r squared plus r minus 1 is equal to 0, such that r1 and 2 are equal to minus 1 plus or minus the square root of b squared minus 4ac, which is 5 over 2. But since r is positive, we only need the plus value, so we get r is equal to square root of 5 minus 1 over 2. And this corresponds to the following possible x values. X has to be between approximately minus 0.618 and 0.618. So now that we know this, we can start with the real solution. Now the key trick to solve this problem is to write our infinite function in a finite way. F of x is known as a generating function, and often we can rewrite these functions. So let me do that now. So what I have done is the following. I started with the normal function, which is equal to x plus f2 times x squared, and so on to infinity. And then I wrote x times my function. And that gives the following power series. And then I multiplied x squared times f of x, and I get this power series. And now I subtracted the second one and the third one both from the first one. And then I get this result. F of x times 1 minus x squared is equal to these two terms plus all terms of the following form. But since we know that f of n plus 2 is equal to f of n plus 1 plus f of n, that means that all these terms end up to be 0. So this is 0, this is 0, 0, and 0. They're all 0. So we get, and by the way, f of 2 is equal to 1, so this is also 0. So we get that it is equal to x. And now we can solve that f of x should be equal to x divided by 1 minus x squared. So we managed to write this infinite power series in a finite way. And now the problem becomes much easier, since we just need to solve this equation. This gives that 3x is equal to 1 minus x squared, such that x squared plus 4x minus 1 is equal to 0. And that gives us that x, 1 and 2, is equal to minus b, that is minus 4, plus or minus the square root of b squared minus 4ac. So the discriminant equals b squared minus 4ac, which is 16 plus 4. So that's 20. So the square root of 20 divided by 2a, which is 2. Now notice that we can even simplify this fraction, since 20 is equal to 4 times 5. And this gives us that x1 is equal to, let's pick the positive, which is square root of 5 minus 2, or x2 is equal to minus square root of 5 minus 2. But this is smaller than minus 2, so the second value definitely doesn't lie in the interval of the radians of convergence. So this is wrong, but this value is actually inside this interval. So we have a unique solution, and the solution is x is equal to the square root of 5 minus 2, which is approximately 0.236. So we solved our problem. If you like this problem and the solution, don't forget to like and subscribe.